Now, this is Nishukris. I am presenting on the topic of graphical representation of data. Presentation of data. This refers to the organization of data into tables, graphs, and charts so that and statistical conclusion can be derived from the collected measurements. There are three basic ways for presentation of data: textual, tabular, and graphical. Textual means statement with numerical or numbers that serves as supplement to tabular presentation. A tableau form is like a tableau presentation of data is like a systematic arrangement of related idea in which classes of numerical facts or data are given each row and their subclasses are given each a column in order to present the relationship of the sets or numerical fact or data in a definite, compact, and understandable form. Now I'm coming to the graphical presentation of data. A chart representing the quantitative variation or changing of variable in pictorial form or a diagrammatic form. A graphical representation is a visual display of data and statistical results. It is more often and effective than presenting data in tabular form. There are different type of graphical representation and which is used depend on the nature of data and nature of statistical results. The main use of graphical representation of data is understanding and identify the patterns of data. Trends and patterns of data. It helps in analyzing large quantities, comparing two or more data, making predictions, and building a firm decisions. The visual display of data also help in avoiding confusion and overlapping of any information. Graphs like line graph and bar graph display two or more data clearly for easy comparison. A graphical representation is a visual display of data using plots and charts. Importance of graphical representation. It is used to make the data understandable to common man. It helps in easy and quick understanding of data. Data displayed by a graphical representation can be memorized for a long time, can be compared at a glance. Principle of graphical presentation of data. The principles of graphical representation are algebraic. In a graph, there are two lines known as axis or coordinate axis. These are x-axis and y-axis. The horizontal axis is called x-axis and vertical axis is the y-axis. They are perpendicular to each other and intersect at O point, which is called a point of origin. On the right side of origin, the x-axis has a positive value and on the left side, it has negative value. In the same way, the upper side of origin y-axis has a positive value and where the down on is with a negative value. When x-axis and y-axis intersect each other at the origin, it divides the plane into four parts, which are called quadrate 1, quadrate 2, quadrate 3, and quadrate 4. This form of representation is seen as frequency distribution that is represented in four methods, namely histogram, smooth frequency graph, pi-gram, or cumulative or called like Ogave frequency graph and frequency polygon. This graph shows the coordinate first, second, right side is first coordinate, and left side upper side right in upper side. In upper right side is a coordinate 1 and which is a positive value, which is so a positive the first coordinate, second coordinate, third, and fourth. Now I'm coming to the constructing diagram. The diagram should have a title and index. Proportion between width and height should be balanced. The selection of a scale must be appropriate. Footnote may include in the graph. Principle of simplicity must be kept in mind. And neatness and cleanness in construction of graphs. Now I'm coming to the type of data for graphical representation. There are two types of data, grouped and ungrouped data. Group when it is organized into frequency distribution, when it refers to a then it refers to as a group data. And ungrouped data is in the form of raw score, like when we have value of age like 13 year 14 years, this is a raw score. And when we say like 13 to 15 and 15 to 17, that is a group data. Type of graphical representation. There are two type of graphical. There are two type of data: ungroup and group data. So for graphical representation, we use four or maximum, but basics is there for ungroup data is by pie diagram, bar diagram, pictogram, and line diagram. For group data, we use histogram, polygon, frequency curve, and Augive. Augive, which is called a cumulative frequency curve. Now I'm coming to the ungrouped data with starting with bar graph or called bar diagram. In bar diagram, data is represented by bars. The bars can be made in any direction, vertical or horizontal. Bar graph can be two types: horizontal bar graph and vertical bar graph. While a horizontal bar graph is applied for qualitative data or data varying over space, the vertical bar graph is associated with quantitative data or time series data. Uh, in summary, we can say that horizontal bar graph for qualitative and vertical bar graph for quantitative data. Bars are rectangles of varying length and of equal width, usually are drawn either horizontally or vertically. We consider multiple or grouped bar graphs to compare related series. Component or subdivided bar graphs are applied for representing data divided into several components. The bars are taken of equal weight and start from a common horizontal or vertical line, and their length indicate the corresponding value of statistical data. When do we use bar diagram? When the data are given in whole numbers. Now starting, I'm clarify that the bar graph is uses only when we have ungrouped data, then where data are to be compared easily. Second is when data are to be compared. When we want to compare the data, then we use bar graph. Bar chart are used for the qualitative type of data. Here the variable studies is plotted in the form of bar along the x-axis. X-axis means horizontal, and height of bar is equal to the percentage or frequency, which are plotted along y-axis. Y-axis means in vertical line. Type of bar diagram. We have some types like simple, multiple, or compound, component, or proportional bar diagram. How to make a bar diagram? Bar diagram or bar graph. First, we started with first simple bar diagram. The following graph is an example of bar graph representing the number of cycle manufactured in month wise. Month is, shows like January, February, March, and number of cycle manufactured in respective month is 600, 800, 1000 up to the 1700. Now this is a bar diagram. I am going to present. Now I have some data. We have month-wise data and the number of cycle manufactured in respective month. 600, 800 up to the 1700. Now I'm going to create a bar diagram. So first we select these two lines. First is month and number of cycle manufactured, and then we go insert and we select bar diagram. So this is the horizontal, and so we also say a bar diagram, also column diagram, column graph. Now we have graph. We saw in January the number of cycle manufactured, 600 number of cycle manufactured, and in February 800 number of cycle manufactured. Now for the multiple bar diagram, we use other manufactured vehicle, which is a motorcycle. Number of motorcycle manufactured in month January, this is 500 and up to the 5550. Now we select both number of cycle manufactured and number of motorcycle manufactured in month wise. Then we similarly we use insert. Then we go into the graph, we select the bar diagram, and we have some pictures which are when title is represent hold the data, hold the table, and hold the graph. which present the table. Now I'm coming to the multiple diagram. Each observation has more than one value represented by a group of bars presented percentage of male and female in different countries, percentage of death from heart disease in old and young age, mode of delivery in different female age group. Now we can say easily कि bar diagram is used for the comparing, like male and female in different countries, what is the percentage of death from heart disease in old age and young age. Compound bar diagram is also for using the comparison, subdivision of single bar to indicate the composition of two divided into sections.
Nishu, we are only seeing your Excel sheet.
Okay,
You have to go back to your presentation.
Compound bar diagram, subdivision of single bar to indicate the of the to the two countries are comparing their proportion of energy obtained from various foodstuffs. Each bar presents energy intake by one community. The height of the bars is 100. It is divided into three components like protein, fat, and carbohydrate of diet. Each component is represented by different color or shape. So we use compound diagram also for the comparison. Now this is my table, and this is bar diagram, multiple bar diagram. And this graph showing the number of cycle and motorcycle manufactured in months. I'm coming to the line graph. Line graph is also used for the ungrouped data. Line graph is a chart used to show information that changes over time. We plot line graph by connecting several points by straight lines. Intervals, ratio, variable. Point representing the frequency of each category are placed above the midpoint of the category and are joined by a straight line. Line graph are simple mathematical graph that are drawn on the graph paper by plotting the data, connecting one variable on the horizontal axis and other variable of data on the vertical y-axis. It is diagram showing the relationship between two numerical variables as the scatter, but the point are joined together to form a line. To form a line, either broken line or smooth curve, used to show the trend of event with the passage of time. So we can easily say that the line graph is using for the showing the relationship between two numerical variable, or we also use for the showing the trends. Graph represented by line segment may be line segments may be considered as a line graph. Line graph is a graph that uses line segment to connect data points and showing changing in data over time. In these diagrams, only lines are drawn from the purpose of comparison. They are not thick and generally their numbers is sufficiently large so that thickness of bars can be used temperature, rainfall, population growth, birth rate. In diagram, if we want to show the birth rate of India from 1991 to 2011, then we can use the line graph because we want to show the trend of birth rate in India from 1991 to 2011. Now here I am just explaining at which time people are maximum coming in the store in between 10 a.m. to 6 p.m. So we have some time 10 a.m. to 6 p.m. and we have number of peoples 1 to 6 one for 10 a.m., 6 for 11 a.m. Now we have some line graph. Now line graph or different trend of income of family in those respective years. We have some incomes, so 20,000, 22,000, 24,000 and 26,000 from the 2009 to 2012. So we have some graph income of a family in particular year. So we previously say that we for showing trend we use line graph, and line graph is like that. Income of a family in particular year. We are using just to a straight line for showing the line graph. Now we want to explain from the Excel some data. We have sub countries, UK, Germany, New Zealand, India, and China. And birth rate is like 2015, 20 for UK and 15 for Germany and 29 for New Zealand and 30 for India and China, for 36 for China. Now I'm coming to coming to show, we can use line graph. Easily we can say, we can show that for now I'm coming to insert, and then we use line graph and 2D line. Now for the income, I want to say show the trend of income of family in the respective years. Now we have some income and we have years. Then we selecting this, and now I'm going to insert, and then we select the line graph, and we have graph. Now I am changing the title, which is the family income in the respective year. We saw a trend from 2009 to 2012. My PowerPoint is on.
Yes, it's visible.
Now I'm coming to pie diagram. It is a circle. It is a circle in which different components are represented through the sections or proportion of a circle. To draw a pie diagram, first the value of each category is expressed as a percentage of the total, and then the angle 360 degree is divided in the same percentage. Then at the center of the circle, these angles are drawn simultaneously starting from a particular radius, consisting of a circle whose area represents the total frequency 100%, which is divided into segments. Each segment represents a proportional composition of a total frequency. In this way, we get a set of sections, sectorial areas, proportional to the value of the. So we can easily say that pie diagram, when we want to show the pie diagram, we have some data which is in percentage form, or we in diagram we show in sector wise. When do we use pie diagram? When data are given in percentage, when different aspects of variable are to be displayed, when data are to be compared normally. Two main formula used in pie diagram for to calculate the percentage of a given data. We use formula frequency divided by total frequency divided into 100 for making percentage. To convert the data into degrees, we use the formula given data divided by total value of data into 360 degree. Now we have a pie diagram. A pie diagram is the best when the total categories are between 2 to 6. When we have from categories from the 2 to 6, then if there are more than 6 categories, try to reduce them by clubbing. Otherwise, the diagram becomes too overloaded. We have some data for number of students and their mark of division. First, second, and third, fourth. We have some frequencies which is in the form of percentage, like 20%, 25%. We have marks of division. First, second, third, fourth, fifth, and student 15, 13, and 10. Then we want to make a pie chart. Then we select. Then we go insert, and then we select pie diagram, and we have some data, and we want to add data label. Then we use this, and we have pie chart. We also called a pie chart as a circle chart. Now we coming to pictogram. A pictogram is a chart that uses pictures to represent data. Pictogram are set out in the same way as a bar chart, but instead of bar, they use column of picture to show the numbers involved. Now this is a pictogram, fruit, pear, a number of children. Now I'm coming to the histogram, which is used for the group data. Continuous data. Continuous data represented on the two-dimensional graph is called histogram. In histogram, the bars are placed continuously side by side without the gap between consecutive bars. Without the gap. In bar chart, we have some gap, but in histogram, we have not gap in the bars. A histogram is a bar diagram which is suitable for frequency distribution with continuous classes. The width of all bars is equal to the class interval, and height of the bars is proportional to the frequency of the respective class. In this graph, bars touch each other, but one bar never overlaps the other. It is defined as the pictorial representation of a group to frequency distribution by means of adjacent rectangle whose are proportional to the frequency. It can be constructed for equal as well as unequal consequence. We can say that there are two types of histogram, like equal histogram, equal class interval, and for the unequal class interval. Area of any rectangle of histogram is proportional to the frequency of that classes. Histogram was first introduced by Carl Pearson in 1891. Histogram is similar to bar chart, but histogram groups numbers into ranges and you decide that ranges to use. When do we use histogram? When data are given the frequency in the group, when we have some class interval, uh, when class interval has to be replaced by a diagram, when we need to calculate the mode of distribution of the graphic line, then we can say that histogram, we can use histogram for the estimating of estimating the value of mode. Mode, we can say that central tendency, measure of central tendency is one of the value which is mode. A histogram is used for quantitative continuous type of data, where on the x-axis we plot the quantitative exclusive type of class interval, and on the y-axis we plot the frequencies. We select in y-axis frequency, and for x-axis so we have some quantitative continuous type of data. The difference between the bar chart and histogram is that since histogram is the best representation of quantitative data measured on the continuous scale, there are no gaps between the bars. We can consider there are no gaps between the bars, which is called a histogram. We have some pictures for this histogram. We show the height of the student in a class 5. Histogram. Histogram, there are two types of histogram: histogram with equal class interval and histogram with unequal class interval. Histogram with equal class interval, example, like in class 5 we want to determine which student have a maximum height. We have some heights, height in class 5, heights of the student, and we have some frequency of the student in class 5. Now the frequency distribution of height of student in class 5, we can say that in class interval 110 to 120, we have two student which height in 110 to 120 centimeter. Now we want to know the which how many students have a maximum height. So we have 6 students which have a maximum height, and this is also show the mode. This is also show the mode value, which also show the maximum frequency. Mode means like maximum frequency. Maximum frequently occurs. So there is a 6 student which have a maximum height. Histogram with unequal class interval. In class 5, we want to determine which student have a minimum height. So in this chart, we want to know the minimum height, but this is also show the unequal class interval. How is this shows the is this first column? This show the height, which is show the height of a student, which is starting from the 110 to 175. But in third row, which show and second row and third row we show unequal class interval. In the width of the class interval is 10. From in first row the width of the class interval is 10, but in second row the width of the class interval is 20. Then it is so the unequal class interval. This graph so now I am showing clearly. This graph is clearly show the unequal class interval. In first bar 110 to 120, we saw width of the class interval is 10, but in second bar 120 to 140, we saw the width of the bar is 20. So this is the unequal class interval, but this is also a histogram. For estimating value of mode, for first we using first example in class 5, we want to determine which student have a maximum height. Now I'm considering equal class interval. Equal class interval means the width of the class interval is same. So there is this is clearly so that the width of the class interval is 10. So the frequency of the class interval is 2, 4, and 6, and the maximum frequency is 6. Now I'm going to represent like this, and we want to know the mode. So we can cross from like this, and in the mid value, which is so the mode. So their mode value is like 138 something. So the mode value is showing the 138. Maximum height means maximum height is 138. Histogram with exclusive class interval. Exclusive means the class interval is excluded. The last now I'm coming to the first column, and third row is the class interval is 110 and 120. Now for knowing the value of for knowing the means of exclusive, the last value is 120, which is not included in the is in this class interval. Then it is so the exclusive class interval. When this is included, then it is called the inclusive class interval. So this is the exclusive class interval. There is a graph for the exclusive class interval, which is normally used. And I'm coming to the inclusive class interval. This is the inclusive class interval, which is clearly so that we have some example, like in book sales, we want to determine which book are most popular. The high price book, the lower price book, 1 to 5, 6 to 10. Then we can show that the 5 are included in the first class interval, 1 to 5 rupees, or 6 to 10 rupees. There is not included in the second column, the second row. We can see that 5 is not included in this, and 6 are included in this, and 10 are also included in this. So we can call this inclusive class interval. So we have some graph like this for inclusive class interval. This is also a histogram. Now I'm coming to the histograph. We can say that histograph is a frequency polygon. Frequency polygon is essentially a line graph, but for group data, because we have some class interval. For histogram, we have also group data and we have some class interval, but for bars, we have ungrouped data and we have not class interval. We have some frequency and some data, some frequency and we have some frequencies and some ungrouped data. We can get it from a histogram. A histogram, if the midpoint of the upper bases of the rectangle are connected by a straight line, but it is not essential to plot a histogram first to draw it. We can construct it directly from given frequency distribution. Yeah. When do we use frequency polygon? When data are given in the form of frequency, when two or more groups have to be displayed in one diagram, when two or more groups are to be compared, and two or more groups can be compared through frequency polygon. Frequency polygon is working same like a line graph. Line graph is also used for the comparing data, but frequency polygon is for the frequency distribution. We have some frequency, some class interval, and for the group data. Or line graph is only for the ungrouped data. We have some example. In class 5, we want to determine which student have a maximum height. We have some height, we have some number of students. Number of students, so the frequency in the class interval 35 students are line in between the first class interval 140 to 145. But for the frequency polygon, we want some mid values of the class interval. Mid value, how to estimate the mid values? We have 140 and 145, then we adding the 140 plus 145 divided by 2, then we got the mid value. When we got the mid value, which is a 142.5, respectively, we estimate for the all class interval, and we have some frequency for the all class interval. Then we estimating the frequency polygon. How to draw a frequency polygon? First we draw the histogram. from the class interval 140 to 145, 150 to 155, 160 to 165, from the respective frequencies. Now we going to draw a now we tick to draw a tick to mid value. For the class interval 140 to 145, we have mid value 142, 142.5. For 145 to 150, we have mid value is 147.5. We easily estimate by the help of 145 plus 150 divided by 2. This is the mean. This is showing a mid value. Now I'm coming to the so the frequency polygon. Now this is exactly frequency polygon graph. The frequency polygon showing the number of students height wise. The maximum student are in 150 to 155 class interval, and which is 55. Okay. First we draw a histogram, then we tick to mid value, and then we meet them with the help of straight line. Then we have frequency polygon graph for the number of student height was. Now I'm coming to the frequency curve. Frequency curve is another type of graphical representation of data. When top points of the frequency polygon are joined not by a straight line but by a curve lines. Curve ones means we cannot use the frequency line straight lines. We just use the smooth curve. Frequency polygon is drawn using scale, while frequency curve is drawn using freehand. We cannot use the straight line, or we just use the free curve. When the number of class interval are very large, width of the class interval are very small, and the total number of sample values we increase indefinitely. Now we have a graph for frequency curve, which is showing a smooth curve. We have not any straight lines. This is also we have used the table of number of student and the height of the students. And same class interval, and we have some mid values, which is for frequency curve also we want some mid values for drawing the frequency curve. Frequency curve showing the distribution of the students height wise. Cumulative curve and ogive. A cumulative frequency curve or ogive is a graphical representation of a commutative frequency distribution. Since a cumulative frequency is either of a less than or more than type, we can say that ogive or cumulative curve is two types, like cumulative frequency less than cumulative frequency curve and more than cumulative frequency curve. We can estimate the value of median with the help of ogive curve. The median value determined through the graphic representation of data in the form of ogive. We have a height of the student, and we have mid values for the respective of the class intervals, and we have a number of the student in the respective class interval. Now I'm coming to estimate the less than cumulative frequency curve and more than cumulative frequency curve. For less than frequency curve, we similarly like number of student is 35. Then first row we have same frequency like 35, but for the second row we just adding frequency number of student plus 35 of first row. 35 plus 40 is 75. Then we adding 75 plus 55 for estimating third row is 130. Then we have some cumulative wise frequency, and this is called a less than cumulative frequency. And for the more than frequency, we starting from the bottom, and for the less than cumulative frequency, we starting from the upper side. Okay, we have now we getting some frequency. Now this is a graph for the less than cumulative frequency and more than cumulative frequency. Now this is a present data graphical in the form of less than ogive and more than ogive. Ogive curve for estimating the value of median. Then we be using in the same graph less than and more than frequency curve, then we have some cut point in the middle. Then we got that 150 something. This is a median. This is a approx median. When we use scaling, then we have exactly estimating the median. So we can say that Ogilvy curve is also used for the median value. Now I'm coming to the box plot. Box plot is using for the knowing the measure of central tendency. For the previous lecture, we can show that the what is the measure of central tendency. So for this, for the estimation of central tendency like a median, mean, and mode, we using box plot. We need to have information on the variability or dispersion of the data. A box plot is a graph that gives you a good indication of how the values in the data are spread out. Although box plots may seem primitive in comparison of a histogram, they have the advantage of taking up less space, which is useful when comparing distribution between many groups or data sets. So we can say that in this previously I can explain you that in ANOVA we use the mean value for the ANOVA for showing in graphical representation in ANOVA in the data analysis of ANOVA. So we use box plot in graphical representation. In ANOVA, for ANOVA 50 taste, we use box plot. A box plot is a standardized way of displaying the distribution of data based on the 5-number summary: minimum value of the data, first quartile of the data, median, third quartile of data, and maximum value of the data, where median is the middle value of the data set. First quartile matlab the middle number between the smallest number and the data set. Third quartile means the third quartile between the median and the highest value of the data set. Maximum Q3 plus 1.5 IQR. IQR means interquartile range. Interquartile range we saw in the graph easily. This is a between Q3, Q1 minus Q3 means first quartile minus third quartile, which is so the interquartile range. Now we have some graph. We have some values for place of residence, for education, and autonomy score and emotional score. We know that the t-test and the ANOVA test are used for the continuous data. So the box plot is also used for the continuous data. So we have some mean Q1, Q2, Q3, and maximum value we can estimate like this. And we have some graph like this. And so, and I want to explain this from the Excel. Go box plot. So I have data for patients, mental patients, is gender, place of resident, education, and autonomy, and emotional score. Now for estimating the value of measure of central tendency, so like mean, median, and mode, then we select autonomy and emotional score. First we want to calculate mean value, then we use this, we can write this like this, and equal to average. Average is similar to the mean, so we can select average. So this this is one to the numbers, so we select the autonomy, and then easily we have some mean which is similar to this. Now now similarly we want to emotional score, then we drag it and we have seen for previously I can calculate this. Now for the quartile value, for the quartile value, first we use the equal sign and then we write this quartile. We have some functions like quartile value. This is also want some data, so we select the autonomy score and comma, and for quartile 1 we use 1, and we have quartile 1 value. This is also same for the Q1. Or for the emotional score, we tagged it. Similarly, we estimating the value, and for the maximum value, we just use it maximum, so equal, just use the sign equal, and then write this maximum. We have we have some functions related to maximum, then we use data for the maximum value of this data. So we have 36, this is the maximum value of this data. So easily we can find for the emotional score. So for the box plot, we just use the data and we are going to insert, and then we select a more column chart, and we have some box plots. Then we use this, and we have a box plot. Box plot for summaries of autonomy and emotional scores. Now we have a box plot. We have box plot which is so that this is a median value 26.94, 27.64. So this is a maximum value, this is a minimum value, and this is a median, this is a Q1 and Q2, and from this also show the value of mean. Thank you. And we have also some graph like a scatter plot which is also show the relationship of the variables.